Hello there, welcome back to another class. So we are going to continue with probability, and this is the second part of the topic probability. And we are going to consider combined events. And in these combined events, we are going to have two kind of combined effects. That is number one, we have a mutually exclusive events, which are known as dependent, and we also have independent events. So these are the events that you're going to consider to be able to understand about the combined events. And we're going to start with the first one, the mutually exclusive events. So these are the events that occurs if one excludes the occurrence of the other. So we have two kind of events that when one occur, the other one cannot occur. Those kind of events are called the mutually exclusive or dependent events. So we can give an example, like when we have a fair coin being tossed once. So the result will either be a head or a tail. So in this case, if a head occur, then we are very sure that a tail cannot occur at the same time. It is either a head or a tail. So in that case, when you toss a coin once, the event, we are going to have an outcome, either a head or a tail, but not the both of them. So that is an example of a mutually exclusive event or dependent event. Another example you can look is that when a fair die is tossed once, so getting 1, a 2, a 3, a 4, a 5 or a 6 are mutually exclusive event. In this case, if we get 3, we are very sure that you cannot be able to get the others, the 1, 2, 4, 5 or 6. It is one of them at any given time. So when we toss the die once, that's an example of a dependent event or a mutually exclusive event. If A and B are two events which are mutually exclusive, then the probability of A or probability of B is given by the probability of A, we add the probability of B. So this is the additional law of probability. So when we have the probability of either A or B, in our case here, we are going to add the two events, probability of A, we add the probability of B. So this is very crucial to our understanding, because now all here we are going to bring about addition. So an example to demonstrate the additional law of probability is that if a die is tossed, what is the probability of getting an even number? So in this case, if you toss a die, we know that a die has sides 1, 2, 3, 4, 5 or 6, and in this case we want to get an even number. So even numbers include 2, 4 and 6. So we need to get the probability of even number. So it is either probability of 2 or 4 or 6. So this case, we are saying when we have or, we are going to add. So we are going to be having probability of 2, we add probability of 4, and then we add the probability of 6. And of course, we know that probability of 2, we only have 1, 2 out of 6 outcome. Probability of 4, it is 1, 4 out of the 6, the two number outcome. Then probability of 6 is 1, 6 out of 6 numbers. So in this case, you're going to be having 1 over 6 plus 1 over 6 plus 1 over 6, which is going to be 3 over 6. This is, we simplify that one, is the same as a half. So That is how you can be able to answer that on a mutually exclusive event. So the other kind of event is now independent events. The first one, you have talked about the dependent event or mutually exclusive. Then the second one is independent events. So when you have two events, A and B, are said to be independent if occurrence of event A does not influence the occurrence of event B. And the opposite is true. So if the occurrence of event B does not influence the occurrence of event A. So in this case, if A and B are two independent events, then the probability of them occurring together is the product of their individual probability. That is, the probability of A and B. In this case, we are going to be having as probability of A, we multiply by the probability of B. So this is the multiplication law of probability. So in this case, we are going to consider as a multiplication law of probability. So when we have add in probability, we consider a multiplication of those two individual events. Let's see an example on the same. If a boy throws a fair coin and a regular tetrahedron with its faces marked 1, 2, 3, and 4, find the probability that he gets a 3 on tetrahedron and a head on a coin. So we have a case here of a boy having a fair coin and a tetrahedron, and we want to find the probability of getting a 3 on tetrahedron and a head on a coin. So we have the probability here of getting a head and a 3 on the tetrahedron. So this is going to be given as probability of getting a head from the coin. Then we multiply by the probability of getting a 3 from the tetrahedron. So probability of getting a head, of course a coin has two sides, so it is we only have one head out of the two possible outcomes, so that is a half. Then we multiply by the probability of getting a 3. We have only one 3 out of the 4, so that is going to be a half. Then we multiply by a quarter, and this is going to give us 1/8. So that is the probability of getting a 3 and a head on the coin. So alternatively, in that question we can draw a table to be able to see the outcome. So we have the coin has the head and the tail, then tetrahedron has a head, a 1, 2, 3, 4. So this is tetrahedron and this one is the coin. So what are the other outcomes? So you can have a head and 1, you can have a tail and 1. In this case you can have a head and 2, and here you can have a tail and 2. In this case you can have a head and 3, and in this case you can have a tail and 3. In the last case you can have a head and 4, and then you can also have a tail and 4. So in our consideration, we want to have a head and a 3. So in this case we only have one instant where we have a head and a 3. So probability of having a head and a 3 will be 1 out of how many outcomes do we have? We have 1, 2, 3, 4, 5, 6, 7, 8 out of 8. So that is another way of answering that particular question. So let's look at example 2. A bag contains 8 black balls and 5 white ones. So if two balls are drawn from the bag, one at a time, find the probability of drawing balls of different colors. So in the first case without replacement, and the second one with replacement. So part A, what do you mean by without replacement? When you draw the ball, we don't return it to the bag. So we want to have the probability of having either a black and white, or we have the probability of having a white and a black. So in this case, we're going to be having probability of B, we multiply by the probability of W. Then when you have O, we are going to add a probability of W. Then we multiply by probability of getting a black. So when we start with black, we have 8 black. So it is 8 out of, we have 12 balls, 13, 8 plus 5 should be 13. Then, now because we have drawn one black ball, and they are not replacing it, then probability of getting a white one will be, we have 5 white, and then we are going to be having a total of 12 balls because we have already removed one ball. Then you're going to add probability of getting a white ball is going to be 5 out of 13, and then when you draw one, you're going to be remaining with the 12 balls. So the probability of getting a black should be 8 out of 12. So 8 over 13 times 5 over 12 should give us 40 out of 156. The same case, 5 over 13 times 8 over 12 should give us 40 out of 156. So when we add the 2, we are going to get 80 out of 156. So when you simplify 80 out of 56, we are going to have 20 divided by 39. So that's one is divided by 4 on both cases. So for part B, we want to get the probability of having different colors of the balls. So remember, you have 5 white ball and 8 black balls. So in this case, part B, we are getting the different colors with replacement. So we take the ball, we check the color, then we return it to the bag. So we want to get the probability of either a white and black, or the probability of getting a black and a white. So probability of white, and then we multiply by the probability of black, or we add probability of a black, and then we multiply by the probability of white. So in this case, we are replacing, meaning for white we have 5 out of 13. We multiply by probability of a black will be 8 out of 13. This one being now, we are going to return the white that you already picked and return it to the bag. So the number of total number of balls are not going to change. This one we are going to add probability of black. We are going to have as 8 out of 13 balls. Then we multiplied by a bit of white should be 5 out of 13. So 5 over 13 times 8 over 13 should give us 40 over 169. We add 8 over 13 times 5 over 13, still give us the same 40 over 169. So we add the 2, we get 80 out of 169. So thank you very much for your time.